Exercise 1102, comparing samples and populations. Anytime you take a sample from a population and whatever data you want to collect about that sample, it's never going to be 100% accurate. The only accurate way to get information is to conduct a census. So, but what we're going to be doing, in the HSC, they only want you doing this for sample sizes of 3. We're not going, even to do a sample size of 5 gets to be a fair bit of work, all right? So, the statistics of a sample can be used to estimate the statistics of the population. As I was just saying, if I want to ask a question of everyone in this class, I might just decide to ask 5 or 6 people and conduct a survey of my sample. It's not going to be as accurate. The information I get will not be as accurate as if I asked everybody the same question. All right? Now, mean. Girls, I know that you've seen that mean is this, X bar. But there is a new symbol that we need to know. And the symbol for the population mean is this. It's called mu. It looks like that. That is called mu. And the symbol for the sample mean is X bar. So every time you've seen mean before, X bar, that's sample mean. The population mean is mu. Mu, you say it mu, but it looks like this, mu. That's the symbol mu. Now, the symbol for the mean of the sample means is this, mu X bar. So this is the mean of the sample means. Now, sample mean is X bar, as we just said. Mu is mean, the population mean. Now, the mean of the distribution of all possible sample means, mu X bar, is equal to the population mean. That will be explained in part 5 of the first question. At the moment, that will mean nothing to you. Clearer as we finish this question. Now, this is similar to question 1 in your textbook. It is not question 1. I took off 2 of the numbers in question 1 because in the HSC, they will only ask you up to a sample size of 3 because it gets too long and too complicated. So, here are 3 numbers. Let's pretend this was a test out of 10. So, we've got 6, 8, and 9. Okay, one of the students did 3 quizzes and they got 6, 8, and 9 out of 10. What is the mean of that? That's the whole population. So what's the mean? It's just the average of that. The mean is 6 plus 8 plus 9 over, how many scores? 3. 17 and 6, 23 over 3. It's 7 2/3 or 7.6 recurring. Now, the next question says, list all possible samples of varying size from n equals 1 to 3. Now, my samples size 1. I've got 6, I've got 8, I've got 9. This is like what we were doing in the last exercise. My sample size 2, choose any 2. 6 and 8, 6 and 9, do you get it? 6 and 8. 6 and 9, and 8 and 9. So I've got 3 possible samples with sample size 1. Do you get it? From that data. I've got 3 possible samples of sample size 2. I can put the 6 with the 8, the 6 with the 9, or the 8 with the 9. And sample size 3, how many possibilities? Just 1. 6, 8, 9. So how many samples do I have in total? 1, 2, 3, 4, 5, 6, 7. Now, okay, let me show you why it's 7 as well. You know how I've got 3 numbers, I'm choosing 1? If you do 3 choose 1 on your calculator, you get 3. If you do 3 choose 2 on your calculator, you should also get 3 if you do it on your calculator. And if you get, I've got 3 numbers and I'm choosing 3 on your calculator, you will get 1. Can you see you got 3 different samples of size 1? I got 1, 2, 3 different samples of size 2. And I only got 1 sample with size 3. So they're my samples. Do you get it? They're my samples. 6, 8, 9. There's sample size 1. There's sample size 2. Combine any two numbers. And combine three numbers is only one way. So last lesson in exercise 1101, we were seeing how many ways can you choose one number out of 3. 3 choose 1. There are 3 ways. How many ways can you choose 2 numbers out of 3? 3 choose 2. 3 ways? Look, I've just chosen 2 numbers out of those 3. How many ways can you choose 3 numbers out of 3? 3 choose 3. That gives me my sample size of n is 1. N is the sample size. N is 2. N is 3. Now, part C. Find the means of all the samples that have been listed. So I need x bar. That's my... So what's the mean of this? What's the mean of 6? So the mean. So I'm going to go for n is 1. My means are 6 for the first sample. For the second sample, it's 8. For the third sample, it's 9. For n is 2, my means are 6 plus 8. I'm just going to show the working. 6 plus 8 over 2. 6 plus 9 over 2. 8 plus 9 over 2. Do you get that? They're my averages. I'm working out the average of each group. Do you get what I'm doing? So they're my groups with 1 number in them. They're my groups with 2 numbers in them. That's my group with 3 numbers in it. That's the average of 6. That's the average of 8. That's the average of 9. This is the average of 6 and 8. 6 and 9, average of 8 and 9. 6 plus 8, 14 over 2 is 7. 6 plus 9 is 15 over 2 is 7.5. And 8 plus 9 is 17 over 2 is 8.5. So they're the averages of my sample sizes 2. And when n is 3, so the groups of 3, there's only one group. The average is 6 plus 8 plus 9 divided by 3, which is actually the same as the first calculation I did in part A, which is 7.6 recurring. Now, the next question, all right, is find the mean mu x bar of the distribution of the sample mean. So I now have to find the mean of all of these. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. There are 7 answers. So I now mu x bar, I add 6, 8, 9. These are all my means. 7, 7.5, 8.5, and 7.6 recurring, and it has to be entered that way, over how many numbers? 1, 2, 3, 4, 5, 6, 7. See how there were 7 possible samples? I do the mean of each of those samples and find the mean of those. I do the mean of the means. What this is the mean of the sample means. Well, what we're trying to show is that this, when you do the mean of all the sample means, you may as well have just done the mean of the original one. It should equal that. So over 7, don't we do it over 7 because there's 7 numbers? I need someone to add this numerator. We've got 14 and 16, that's 30. 53 over 7. Can I have that done on your calculator? Just go 50. You should get 7.6 recurring. That's what you're supposed to get. And part E says, does the mean of the sample means equal the mean of the population?
Yes.
Well, mu, which is the mean of the population in part A, so from part A, mu, which is the mean of the population, was also 7.6 recurring. So the answer is yes. The mean of the means. The mean of the distribution of the sample mean. So the mean of the means equals the mean of the population. So on your calculator, 0.6, to enter 7.6 recurring, you go 7 2/3.
Can we just say the answer is always 7.6?
So this is the whole population, three numbers. So the mean of the population, mu, is now what you use for mean of population. But only in this type of question where you're doing mean of the means. For the rest of the exam, it's just X bar. All right, so it's 68 plus 74 plus 72 divided by 3 divided by 3, and we get 1.3 recurring. Okay, samples are taken from this population. It's not asking you to list them. Find the number of samples of size n is 1.
N is 1.
So you can just do 3, choose 1, but wouldn't you have 1, 2, 3? So it's 3, choose 1. Do you know what I mean? I could have that, that, or that. There's 3 different samples of size 1. Sample size 2 is 3, choose 2, or you could say I'll have those 2 together, these 2 together, and those 2 together. If you do that on your calculator, 3, choose 2 is 3. Because every time you're choosing 2, you're leaving 1 out. So it should be the same answer as 3, choose 1. And how many ways can you choose the 3 numbers? There's only one way. 3, choose 3 is 1. Or I can see it. How many ways can I choose a sample size of 3? It's just 1. The 3 numbers have to be in there. Now it says list all the possible samples of varying size from n is 1 to n is 3. So can you list all your samples of size 1? What have you got? You just list them individually. What are they? Anyone? 68, 74, and 72. I'm just going to put brackets around them so you know that they're samples. What about groups of 2? I need groups of 2. 68 with 74. 68 with 72. And 74 and 72. And I need the possible samples of size 3. It's just all of them. So 68, 74, 72. Our sample sizes of 1, 2, and 3. Part D, find correct 2 decimal places, the mean of each sample, and then calculate the mean, which is mu x bar, of the distribution of the sample means. So for n equals 1, our means are, well, that's just got a mean of 68. That's got a mean of 74, and that's got a mean of 72. For my sample size 2, what's the mean of 78, 68, and 74? You've got to work it out. I need the mean of 68 and 72. These should actually be nice values because they're all even numbers. Oh, that should be nice too. That's 73. The average of 74 and 72. The average of 68 and 74. What's that one? Is that 71? And the average of 68 and 72 should be 70. And the average of 74 and 72 is 73. So you can do them on your calc, but they're actually not that.
The n equals 3.
The n equals 3 one is just the mean of the original of the 68, the 74, and the 72, which we've already done before, which is 71.3 recurring. That one's actually not even needed, but no, it is. But it doesn't change the mean, like it doesn't. Well, it does, I suppose it does. Sorry. Okay, now what do? Now, mu x bar. So girls, can you see this is asking you for the mean of your means? Do you get it? The mean of your means. So, write down all your means, 68, 74, 72. These are all my means. 71, yep, 71, 70, and 73, and 71.3 recurring. How do you do 0.3 recurring on your calculator? It's a third. That is 71 and a third on your calc. Over how many samples are there? 7. Mean is number of scores, sum of scores over number of scores. There are 7 means. 1, 2, 3, 4, 5, 6, 7. And your answer should be 71.3 recurring. which is
always divide by 7.
mu x bar, the mean of the sample means equals the population mean equals mu, the original one that I just did. Okay?